Hey PreCalc. It looks like you'll be watching this on Thursday. Oops, Wednesday. Yeah, Wednesday, not Thursday. You'll be watching this on the 8th. So, I will be starting our review. So here are the topics that we'll be testing on whenever we decide to test. So, we'll be graphing exponential functions. That was the first thing we did. We learned compound interest, money problems, and continuously compounded interest. Logarithms, log rules, condensing, expanding with use of log rules, graphing log functions, solving exponential functions, or solving exponential equations, solving log equations, and we ended up recently doing continuous exponential growth problems and other log models. Alright, so if you need to write that down, just pause the video and do so. I'm going to begin going down that list and reviewing some principles, and in class we'll be practicing problems. The first thing on our list was graphing exponentials. An exponential is an equation, a function, with the unknown in the exponent. So the first thing we did was graphed this, and this. Alright. So, if you forget, we can always do a sissy chart with 2 points on it, and those points are going to be 0 and 1. Anything to the 0 is 1, so this point is on all of them, and then this point is different for each logarithmic expression, exponential expression. So that should tell us the tail is over here and it goes zinging up like this. And just recall, if we were doing y equals log, say, not log, I'm stuck on logs tonight. We'll get there, but right now we're doing exponentials. Y equals, say, 5 to the x. How will that look relating to this one? Well, it'll still go through this point. We still have 0, 1, but when x is 1, y is 5. So it's going to be, the zinging up part is going to be inside, and the tail is going to fall off quicker. Alright, so a function that would be in between these two would be y equals 4 to the x or y equals 3 to the x, whereas y equals 10 to the x would be way inside of this one, and that's the relationships I want you to notice. Now, what happens when we put a negative hugging the x? That is the same as 2 to the minus 1 to the x, which inverts this. It's the same as 1/2 to the x. So, if we were doing a sissy chart for that, we would have 0, and we took 1, we would get 1/2. And let's say we would take -2. A -2 as an exponent will flip this. It becomes 2 to the 2, which is 4. So 0, 1 right there again. 1, 1/2. So you can see it's going to tail off on this side. -2, 4. tails off and goes up this way. So if you forget, you can always do a chart, but we learned that a negative sign here will flip across the y. Flip across the y-axis. That's what that negative sign does. This negative sign will flip across the x-axis. So this irregular function here, the very first one we drew, will flip across the x-axis and look like this. So let me write these in. This one was y equals 2 to the x, y equals 2 to the minus x, and y equals negative 2 to the x. And there's one more, and that's when we have both of the quantity parts of the expression negated. So that will take this and flip it across x, and flip that across, we'll flip that across y, and then flip that across x. So we have y equals negative 2 to the negative x. All right. I didn't express this to you when we learned this, but I want to add this to our test. What happens if I take the regular function and add 3 to it? Y equals 2 to the x look like this. And when we put a plus 3 here, it just raises it up 3. And we practiced that with when we were doing log graphs. Same principles. Alright, so there it is. What if I had the minus 3 wasn't, say I didn't have a plus 3 here, but I had it up here. So now the plus 3 is hugging the x. It's inside the argument. So therefore, it is a left or right transformation, and it's opposite what you think. So a plus 3 is actually to the left. So I draw the regular, y equals 2 to the x, and I'm going to move this. I usually move it, I pick a spot and move that. So I'm going to move it to the left 3.